Good afternoon, ladies and gentlemen. My name is Mohit Manoj Padi, and today I'll be making a presentation on the impact of global warming on the Gold Coast. Throughout the presentation, I'll be showing you the ANOVA data, the qualitative and the quantitative analysis, providing key recommendations and the issues that need to be addressed to make sure that there is sustainable tourism on the Gold Coast of Australia. So my presentation today has a table of contents, and as we can see through the table of contents, I'll be introducing the Gold Coast. I'll be giving you information about global warming and SDG 13, the expectations and the trend of the rainfall and temperature, as well as a qualitative and quantitative analysis, and then some key issues related to global warming and some recommendations. So we start off with an introduction to the Gold Coast of Australia. Australia's Gold Coast is located in Queensland. It is known for its very diverse array of beaches and other recreational options. Some landmarks include Surfers Paradise and Burleigh Heights, which are located within 70 kilometers of the coastline. And with 300 days of sunlight in a year, it is a very popular tourist destination for people to come and just relax. And some people who are concerned about the environmental initiatives, it has very sustainable ecosystems and it promotes a sustainable living. It provides a lot of events and offers a lot of amenities, not just to the residents, but also to the tourists that engage in these places. So now I'll be introducing what global warming is and what is SDG 13. So global warming basically involves a long-term rise in the temperature of the Earth's atmosphere because of many reasons such as the burning of fossil fuels, deforestation, and industrial processes. Two gases that are released during this process include carbon dioxide and methane, which basically trap heat in the atmosphere and causes global warming. Now, a way to basically combat this is the United Nations Sustainable Development Goals, or SDG. This SDG 13 basically aims towards reasonable climate change, addressing climate change and its effects by basically providing education, doing different methods and measures, and developing different policies to basically reduce this. So we'll be looking at the expectation of trends for temperature and rainfall. Right off the bat, we can see that the temperatures are basically expected to rise steadily. What this means is that the annual average temperature will be more compared to the last few decades, with days becoming expected to be hotter and hotter and less cool days to be expected. This pattern is basically consistent with more general Australian forecasts, as it has been taken as evidence in order to support the argument. With respect to rainfall, it can also be seen that the rainfall patterns are expected to be very variable. This basically means that there can be small chances with occurrences of flash floods, heavy rainfalls, etc. And the total rainfall quantity would either stay stable or it would decline. Now we have the graphs on the forecast for temperature. We can see it is there for summer, autumn, winter, and spring. We can see the upper and the lower confidence bound, where it is more likely to reach the upper confidence bound at 95%. The same can be said for rainfall. The summer, autumn, winter, and spring graphs have been presented as shown with the upper and lower confidence bound to basically give you an idea of what is to be forecasted for the future. So when we look at the quantitative ANOVA analysis, there's some things that we can look at straight off the bat. The first being when we look at it on the ANOVA analysis for rainfall, on the aspect of rows, which is seasons, the p-value being less than 0.05 at 8.85 into 10 raised to the power minus 5 basically shows the statistically significant differences among average rainfall for seasons. But when we look at it from the temperature perspective, we can see since it is greater than 0.05, there are no statistical significant differences among average rainfall for years. Now we analyze that for temperature as well. In both scenarios, we can see that the p-value is less than 0.05. What does this indicate? This basically indicates that for both seasons and years, there is statistical significant differences between the average temperature. So when looking at how forecasts align, we can see that the variance from the ANOVA data was significant, which basically means that the more variable rainfall patterns match with the forecasting. The second thing that we can see that is due to the high variance, we had initially forecasted that there will be more intense episodes of rainfall and flash floods, which also looks very likely. When we compare it for temperatures from the ANOVA data for years, we can see that the value was very significant at 6.6 E minus 0.5, which basically indicates that the temperatures are rising. The same way, we can see the trend of generally higher average temperatures, which matches with the forecast that we had made, that initially there will be less cooler days and more hotter days. When we look at where forecasts diverge, we can say that according to the expectations, it does not provide any conclusive evidence to show that the rainfall patterns are decreasing or staying stable, because ANOVA analysis only provide us with variations for the years and seasons, and in order to fact check it, we would need to do further regression analysis. The events are also too localized, which means that it captures averages and variances rather than the short-term intense rainfall events. The same for temperatures. It can be observed that the forecast suggests a steady rise, like the seasonal variance, but the ANOVA highlights that some seasons like winter have basically less pronounced temperature increases than others, leading to variability. Look at the qualitative analysis aspect, we can see for the tourism asset which I have chosen, which is Surfers Beach Paradise, the mind map has been shown where there are a lot of good experiences in the thematic analysis. Positive aspects like beach features, friendly environment, there's negative aspects like crowds and behavior and parking challenges, and mixed experiences like nightlife and tourism overload. So now we'll be looking at the qualitative analysis aspect and how global warming has basically had an effect in many different levels. So the first one is erosion of sea levels. Basically, as there has been erosion of sea levels, it has caused a challenge in maintaining the scenic beauty. The impact on marine ecosystems due to the rising ocean water temperature, it affects the ecosystem of the marine life. Overcrowding and strain on resources. So obviously, due to climate change, there is a lot of overcrowding and there's a lot of strain on resources, which affects tourism patterns. Weather extremity and coastal safety, so there is always a risk of unpredictable events and forecasts, as well as just shifts to sustainable tourism, as people may prefer less crowded areas and other friendly alternatives. So now we'll be looking at some key issues related to global warming. The first key issue comes out as rising temperatures. As we have seen from the forecasts, due to a rise in temperature, what basically happens is there's an increase in the frequency of heat waves. Then there are coastal risks. As we know, there's rising sea levels due to the increase in temperatures. This will basically lead to more storm surges, and this will basically put infrastructure at risk. Then we have extreme weather events. As we already know, Australia is known for its frequent storms, cyclones, etc. This is basically damaging the coastline and the infrastructure, as well as increased fuel load from the wetter years, which are basically causing significant damage. Then we look at its impact on ecosystems and coral reefs. So as we know, due to global warming specifically, there is an ocean acidification process which continues to harm the wildlife inside, as well as the coral reefs. There's a lot of coral bleaching on the Great Barrier Reef. Some key recommendations that can be given from the ANOVA analysis includes basically providing shaded outdoor experiences, cooling infrastructure, encouraging an off-season travel to ensure there is no rushing out, having a flexibility. As we know, there is a variability in rainfall, which may cause flash floods, so being flexible always helps the cause. Using renewable energy and carbon footprint production, basically using stuff like solar energy, putting waste management systems to reduce greenhouse emissions, as well as just giving some coastal management practices, educating the community about all of this should help stir the cause. Now, as I look to conclude this report, I would basically say that the ANOVA analysis basically help us to understand the wider effects of climate change, and it shows variability in both temperature and rainfall. This basically is accurate because it tells us about the rising temperatures as well as the variability in rainfall leading to flash floods. Now, if this continues with the future trend, we can see that these weather occurrences may become more and more extreme and could basically interfere with the natural ecology. And if we follow these recommendations that have been given in the previous slide, we can basically counter this. Now we'll be looking at the ANOVA analysis for temperature, which I had explained in the previous slides. And now we'll be looking at the ANOVA analysis for rainfall, which has also been explained in the previous slides. And I would like to end this presentation by showing the references, and I would like to thank everyone for taking their time out of their day to listen to my presentation, and I hope that these changes can be implemented in order to help the Gold Coast grow into a bigger tourist destination.